All right, so in this video, we're going to have a little bit of fun. I know you don't usually think of that when you see Jackson's Classical Electrodynamics. I don't think I've opened this since my maybe second year of grad school. So yeah, this is the first time in a while. What I'd like to do is take some of Jackson's text and put it into Google Translate back and forth a couple times and see what kind of ridiculousness results. Let's see, why don't we try, what should we start with? Not the preface. Ooh, yeah, let's consult the table of contents. I think what I want to do, I want to translate his stuff about Green's functions because that just, oh gosh, that kept us awake a lot in grad school. Let's see, where does he get into Green's functions? Here we go. Formal solution of electrostatic boundary value problem with Green function. It's not a Green's function, excuse me, it's a Green function. Let's go to page 38. All right, page 38. Okay, cool. So the solution of the Poisson or Laplace equation in a finite volume V with either Dirichlet or Neumann boundary conditions on the bounding surface S can be attained by means of Green's theorem and so-called Green functions. Okay, yeah, no, this sounds great. We're going to do this. Let's go. The solution of the Poisson or Laplace equation in a finite volume. And here's the thing, I'm just going to skip the symbols rather than having to translate, letters with either Dirichlet or Neumann boundary conditions on the bounding surface can be obtained by means of Green's theorem and so-called Green functions. Let's see, should I keep going? Yeah, let's get a few more sentences in there. In obtaining, this result, I'm not going to put in the equation number, not a solution. We chose the function to be something, 1 over x minus x prime magnitude, it being the potential of a unit point source satisfying an equation involving the delta function. This function is only one of a class of functions depending on the variables position and other position, that's x and x prime, and called Green functions, I can't make that italics in here unfortunately, which satisfy the previous equation. In general, the Laplacian of a Green function equals a delta function where the Green function equals our previous function plus another function with the other function satisfying the Laplace equation. Laplace equation inside a volume. And again, that's taking out some of the equations and such and just replacing them with words. Okay, cool. So that's nearly 787 words. Yeah, cool. Let's start with that. So this is his opening statement about Green's functions, or excuse me, Green functions. All right, how should we? Let's see. What language do we want to go to? Let's try. I feel like let's go Chinese. Well, you know what? No, let's start near English first, and then we'll work our way away from that. So let's try. I'm gonna try Espanol. Let's get to Spanish. Spanish. There we go. All right, so we're gonna translate this to Spanish. Okay. Here's what I'm gonna do. I'm gonna take this and copy this, put this in a notepad because I do not want to have to type that again. I probably should have typed in a notepad to begin with. All right, so there's the original. All right, so now we're gonna grab this, copy. I'm gonna go to detect language. Paste. We're going to go to English. Okay, the solution of the Poisson or Laplace equation in a finite volume. So let's try to read this side by side. There we go. The solution of the Poisson or Laplace equation in a finite volume with boundary conditions of Dirichlet or Neumann on the boundary surface. A finite volume with either Dirichlet or Neumann boundary conditions on the bounding surface. With boundary conditions of Dirichlet. So it got rid of the either. That's interesting. When obtaining this result, as opposed to in obtaining this result, okay, not a solution, we choose that the function is something. Okay, instead of the function to be something, since it is the potential of a single point source saturating an equation that involves a delta function. Saturating. Oh, saturating, satisfying? So it turns satisfying into saturating. That's interesting. An equation that I never thought about saturating an equation before and involves a delta function. This function is only one of a class of functions that depend on the position of the variables and another position and are called green functions, which satisfy the previous equation. Green got demoted to the color green, which makes total sense. In general, the Laplacian of a green function is equal to the delta function, where the green function is equal to our previous function plus another function with the other function that satisfies the Laplace equation within a volume. With the other function that satisfies, the other function satisfying. Okay, so that doesn't get too far off. There's a little bit lost and some interesting changes there. Okay, let's switch now. Okay, all right, let's grab the Spanish now. Copy, text language, paste. Oops, excuse me. Not Spanish to Spanish, go Spanish to English. The solution of the Poisson or Laplace equation in a finite volume can be obtained by means of the green function of the green theorem. Okay, and the so-called green function. Well, I'm kind of impressed it got so-called. I wouldn't know how to say, how do you say so-called in Espanol? Y las llamadas funciones de green. Okay. When obtaining this result, not a solution. Okay, so this came out about the same. Okay, so we seem to have reached a fixed point here. We'll go copy and then paste in here. It'll detect English. We'll go to Spanish and then we'll do copy, exit here, paste Spanish, go to English. Okay, that doesn't end up too terribly. Okay, yeah, I think we end up with a fixed point there pretty easily in this transformation back and forth. All right, let's go back to the original now. Let's try something a little more afield from English. Let's try Chinese. Chinese, simplified Chinese traditional. Let's go traditional. Okay, so it's putting in Neumann, Poisson, Dirichlet, and Laplace. That makes sense. Now, can I just copy this and paste it in here? I think, yeah, it keeps the characters. Okay, let's go to English. Solutions to the Poisson or Laplace equation in a finite volume with Dirichlet and Neumann boundary conditions on the boundary surface can be obtained by Green's theorem and the so-called Green's function. Okay, it says solutions plural instead of the solution, but you know, that's kind of the same thing. In obtaining this result, okay, it kept the in obtaining this result rather than the solution. Yeah, that's interesting, not a solution. That's interesting. We chose the function as something which is the potential of the unit point source. Okay. Which satisfies the equation containing this incremental function. Oh, that's interesting. It took delta instead of the letter delta to mean incremental function, to mean increment. Like when we say delta x equals an increment in x. That's interesting. That's gotta be a Surely that's a choice on Google's part and not a exact translation. I don't know. That's interesting. This function is just a type of function. So it goes from is only one of a class of functions, meaning, well, only one meaning singular, to just, like it's only a type of function that depends on the position of the variable and other positions, called the Green's function, which satisfies the previous equation. In general, the Laplacian of the Green function is equal to the delta function, where the now there it kept delta. Okay, so why would it change? Oh, this was supposed to be a possessive. I don't know that makes a huge difference. Okay, let's switch it back now. Let's change it back. Okay, so let's go copy paste into Chinese. I have no idea whether the Chinese are the same. Copy paste. Go back to English. Solution to the Poisson or Laplace equation in a finite volume with Dirichlet or Neumann boundary conditions on the boundary surface can be obtained by Green's theorem and the so-called Green's function. Ooh, so now we're back to Green's function. Ooh, we got the somehow Google appended the possessive on there. In order to get this result instead of the solution, oh, now it's rather than the solution instead of the solution, as if we'd rather not have a solution. We chose a function as something, which is the potential of a unit point source, which satisfies the equation. This function is just a function that depends. This function is just a function. Right, this function is only one of a class of functions. Okay, so we've gone from this function is only one of a class of functions to this function is just a function that depends on the position of the variable and other positions, called the Green's function. And other positions, what? Oh, and the other position. Okay, got it. In general, the Laplacian of the Green's function is equal to the delta function, or the Green's function. Okay, yeah, we still have incremental function there. Okay, all right, let's do this one more time. Copy, paste, Chinese. Grab the Chinese, copy, paste into English. Solutions to the Poisson or Laplace equation in a finite volume to get this result instead of the solution. Okay, we seem to have reached a steady state here. You know what I hate to say? The fact this is so stable under all these translations kind of suggests to me maybe this is actually written really well. I may owe Jackson an apology for all of my complaints about his textbook. Okay, but let's have a little bit more fun here right at the end. Let's go through several languages. Let's go from English to Chinese. We're going to go from Chinese traditional, copy paste. Let's go into Russian. There we go. And then we'll copy and paste the Russian. There's Russian. All right, let's go from Russian to Yoruba. How about that? All right, let's do a copy here. And then paste. And we'll go from Yoruba to, let's go into Greek. Why not? Go. All right, let's grab Greek, copy and paste. All right, it has detected Greek. And finally, let's land back in English. Oh my gosh, this is so amazing. Okay, let's get these side by side. The effluents of the Poisson or Laplace equation have a finite dimension with the Dirichlet or Neumann boundary conditions on its boundary surface with the Green equation and the so-called Green function. In obtaining this result, and not as a solution, boy, they really hammer that home, we choose a function as the probable component of a field source that satisfies an equation that has an additional function. This function is a function type, depending on the state of the variable and other conditions, called the Green function, which satisfies the previous type. Normally, the Laplacian of Green function is equal to the delta function. Wow, the delta function survived. That's great. Where the Green function is equal to our previous function with another function satisfying the Laplace equation in volume.